So worked example 1, we are asked to find the time taken for a particle to reach a surface when it's projected horizontally at 25 meters per second from a height of 78.4 meters. Okay, and then we have to find the horizontal distance it's traveled. It's a good idea to draw what's going on so you can see and then decide what your frame of reference is going to be. So we've got a horizontal line. So that will be my vector, my velocity vector going to the right. And that's 25 meters per second. Okay. And then it's going to descend 78.4 meters. So the path it's going to take will be something like this. It's going to fall. And at some point it's going to hit the ground. So let's put the ground in as well. Okay. So it's horizontal ground. So we'll put that in. And we've just got to decide what our origin is going to be. We could either mark our origin on the ground or from the point in which the particle was projected. So I'm going to go for the latter. And if we put on our frame of reference, so we'll put this on in green, we're going to have the vertical axis here, which is my Y direction. And the horizontal axis here is my X direction. So my origin is the point at which the particle was projected. Okay, so there's our reference frame. So I'm taking up as positive and right as positive in the X direction. So how do we solve this? We need to find the time taken for the particle to reach the surface. Well, we're going to use suvat, and we can use suvat in 2 dimensions. So for part A, let's list our suvat variables, SUVAT, but because we're working in 2 dimensions, we're going to do it in 2 different stages. So I'm going to call this stage the horizontal direction, going to the right, and we're going to take right as positive, okay, because there's my positive X direction and there's my positive Y direction. Okay, you don't have to do that. It's just as long as you're consistent, it doesn't matter. Okay, and also I'm going to use subscripts. So because I'm working in 2 dimensions, in the X direction, there is a horizontal displacement, which I'll call S sub X. There is a horizontal initial velocity, U sub X. And similarly with the velocity and acceleration. The only difference is that time, because time is a scalar and it's consistent, it's the same for both horizontal and vertical, we don't need to put a direction on that because time doesn't have a direction. Okay, so let's write down what each of these quantities is. So the horizontal displacement, well, that's we're going to find that in part B. So we don't know that. The horizontal velocity, though, we know is 25 meters per second because that's given to us in the question. Okay, we don't know the final velocity for the horizontal direction, but we don't need it at the moment. And we know the acceleration horizontally is 0 because there is no force acting horizontally because we are ignoring air resistance. So it's 0 meters per second squared. So you may notice a problem at this point. We only have 2 out of the 5 variables. So we don't actually, or we can't use any suvat equations. So let's move over to the vertical direction now and see what's going on here. So vertically, I'm going to take up as positive. We have the same situation. We have constant acceleration in the vertical direction. So let's write down our suvat. So S, U, V, A, and T. And we're going to use the subscript Y for this because we're going in the Y direction. So we have a vertical displacement, a vertical initial velocity, a vertical final velocity, and a vertical acceleration. Okay, time, though, as we just described, is the same for both horizontal and vertical. So time is the glue that knits these 2 things together. Okay, right. Let's have a look at the vertical direction. Well, if I'm taking Y as positive going up, then my vertical displacement is actually going to be negative, isn't it? Because I'm actually going to be traveling down 78.4 meters, which is what it says in the question. So that's my vertical displacement. It's negative. If you take down as positive, then it's not going to be negative, but that's completely up to you. Like I said, as long as you're consistent. For the next quantity, what do we know? Well, if we're traveling vertically and we were projected horizontally, there is no initial vertical velocity at all. It's as if it's falling from rest. So we can write that uy is equal to 0 meters per second. So that's useful. V we don't know, and the acceleration, because it's due to gravity and because I'm taking upwards as positive, that must be negative 9.8 meters per second squared. So this is good news. We have 3 out of the 5 in the vertical direction. So we can actually figure out either V or T, and let's see what the question asks us to do. Well, we have to find T, don't we? So for part A, which I'll do under here because that's where all the values are kept, we've got S. Let's just tick these off. So we've got S, we've got U, we've got A, and T is what we want. So it's going to be the one we use most often. It's S equals UT plus half AT squared. Just bearing in mind we're using the Y components here. So that means that negative 78.4 is equal to UT. Now U is 0. I'll put that in here. 0 times T plus a half AT squared. Well, half of A is going to be negative 4.9 T squared. So we just have to do some rearranging. I'm going to add 4.9 T squared to both sides, and I'm going to add 78.4 to both sides just to make everything nice and positive. And if we divide by 4.9, you'll discover you get T squared is equal to 16, and therefore T is going to equal 4 seconds. Now, it's a quadratic, so you would get plus or minus 4, but remember that time is always positive. So that's good. So we've got part A, and for part B, we now have enough information to complete the question because we have just discovered that time is equal to 4 seconds, and that is the same for both horizontal and vertical. Okay, the frame of reference does not matter. So let's put in T, and we're going to get, what do we want to find? We want to find the horizontal distance traveled. So let's just highlight what we know and what we want to find. So we want to find S, we know U, we know A, and we now know T. So let's plug everything in. So it looks like we're going to use the same formula again. So it's going to be S equals UT plus 1/2 AT squared. And the horizontal displacement, Sx, is going to be quite simple because it's going to be the U component, 25, multiplied by the time, which is 4. And then that second term, the half AT squared, is just going to be 0 because there is no horizontal acceleration. So this is nice and simple now. So the horizontal displacement is just going to be 100 meters. So it's worked out rather nicely.